Okay, this is chapter 6, enthalpy changes. Talk about a pretty big chapter, especially with calculation of enthalpy. We'll talk about what enthalpy is and how it can be calculated through 3 different areas. One is experimentation, 2, Hess's law, and then 3 is bond energy. So the first thing is, we'll take a quick review on what energy is in a reaction. So a chemical reaction occurs, things change, you get energy. And the form of energy could be heat, light, electrical energy, even sound. So for example, in exothermic reactions, you burn fuel in an engine, it gets hot. Same thing with a gas grill, you burn the gas and you cook your food. Fireworks explode, it generates heat, sound, and light. That's why you get the oohs and ahs, and the sound can be bad for certain animals. Oxidation of food helps our body keep warm, so it gives us energy to stay warm and to breathe. Endothermic reactions, photosynthesis is a most common endothermic reaction. It takes energy in from the sun and it produces carbohydrates, fuel. Or even melting of ice is a endothermic process. It absorbs energy in and the solid turns into liquid. So what are enthalpy changes? And the major type of reactions are exo and endothermic reactions. We know exothermic releases energy in the form of heat, so temperature goes up. Combustion reactions, oxidation of food, even just mixing solids most of the time in water will generate heat. Endothermic reactions, they absorb energy, so temperature goes down. The reason why absorption energy is occurring is as the temperature goes down, it needs to absorb energy from the surroundings to get back to room temperature. So some type of reactions, some salts, when you dissolve it in water, do get cold, like ammonium chloride. And just ice packs in general, like when you break the ice, those are endothermic processes. Okay, so temperature goes down. So if you put energy into something, like heat, it will decompose, and that's an endothermic process. We just talked about photosynthesis last slide. Okay, so what's happening in a reaction? So what's happening to energy of these compounds during a reaction? So we call this an energy profile. Basically, it's just a diagram of showing what's happening to an exothermic and an endothermic reaction. So in an exothermic reaction, notice you have reactants at a certain amount of energy. Okay, energy is on the x-axis, and it reaches to a point that absorbs energy to break apart, and that's called the activation energy. Once you reach the peak of that activation energy, then the molecules will reform and you dip down in energy. Now when the energy dips down, notice the energy of the products is a lot lower than the reactants. So when you do the calculation, you notice that the change in the products minus the reactants will provide a negative value. That's why energy is releasing. That's why it's exothermic. That's why enthalpy is negative. You can plug in any number you want. If you have a product that's lower than the reactants, you will get a negative value. Now the opposite's true for an endothermic reaction. Notice the reactants again start here, but when you reach the activation energy and the products form, the product energy is a lot higher than the reactants. So when you do the math, a number that is higher in the products minus something on the reactants that's lower will generate a positive enthalpy. So you get an endothermic reaction. So enthalpy is positive. So go back and look at the two types of enthalpy profiles. Do one example of combustion of sulfur. That's going to be an exothermic reaction. So sulfur plus oxygen makes SO2. And an endothermic reaction, which is mixing of carbon and water, and you get hydrogen gas and carbon monoxide. You don't have to provide values, you just have to show a relative change between the reactants and products, remembering that the reactants have to be higher for exothermic reactions, and in endothermic they are lower than the products. The reactants are lower than the products in endothermic reactions. Alright, so these are the types of different enthalpy changes that go on. So in enthalpy reactions, it's a general term that is any reaction provides enthalpy, and there's different types of reactions that occur. We know through chemistry that there's different reactions, synthesis, decomposition, combustion, all that stuff. So enthalpy is no different. You have 6 different enthalpy terms that are generalized or specific towards different reactions. So the most common two are the first two. Formation reactions. It's very, very, very important to understand how a formation reaction is produced. Combustion is also a very important enthalpy reaction that you need to understand. The other ones are not as common, but also important, especially if you move on to other chem courses. So you have enthalpy of neutralization, that's just an acid-base reaction. A enthalpy of solution, that is basically making a solution, so adding a solid to water. Enthalpy of atomization, that's basically just using diatomic elements into their single element. So it's a very specific enthalpy reaction, but very important to later on. And then the hydration of a salt, that's just adding water. Hydration, just like drinking water to stay hydrated. So we're going to the specific ones. First is a table that will help understand a little bit more examples of these 6 types of enthalpies. So the first column, the enthalpy of reaction, basically just is a general term. Anything falls under a enthalpy of reaction. Okay. So specifically a formation reaction, formation is its basic elements. So basically you're just taking a compound or a molecule and seeing what elements you need to make that element or compound. The biggest thing is that you need to know that the product, when you're balancing the reaction, the product always needs to be 1 mole. Combustion, anything that reacts with oxygen is a combustion reaction. So enthalpy of reaction for combustion is anything with O2. Now notice that you could have a formation reaction with just O2 as well, because O2 is elemental, which is true. So they can kind of intertwine somewhat. But a combustion reaction is always exothermic. It always releases energy. Whereas a formation reaction could be both endo or exo. So those are the 2 major ones right there. So the other 4, neutralization, again, acid base, pretty simple. It's always exothermic, just like combustion. Solution, mixing a solid into water or a solvent. Majority of times it's water. So like sodium hydroxide mixed with water gets warm, it's exothermic, but if you put ammonium chloride in water, it gets cold. So it can be endothermic. So that can be anything from exo or endo. Atomization, basically you have a diatomic element, as hydrogen is shown, and you're breaking apart into its atom. That's why it's called atomization. That is strictly endothermic reaction because you're putting energy in to break apart the molecule. And then hydration is adding water to a solid, and you make a hydrate. So anhydrous salt is anything that's not bonded with water, and then a hydrated salt is called a hydrate that has bonded with water. And again, that can be exo or endothermic reactions. So the only endothermic reaction that has to be endothermic is atomization, and the other exothermic can be combustion or neutralization. So we're going to specifically go into enthalpy of formation reactions because, like I said, it's one of the most important enthalpy reactions to know. It can be exo or endothermic reaction, but you gotta remember that the product is always going to be 1 mole. Here's some examples. Iron, 2 iron atoms with 3 halves of an oxygen molecule makes 1 mole of rust, iron oxide. Notice the exothermic part, the negative delta H. Carbon plus 2 sulfurs makes CS2, and that is endothermic with the plus notation. So again, they could be both exo or endothermic reaction. So remember that the product is always 1 mole, so you can see that there. So how do you write a formation reaction? 1, you start with the product you want to form. So they tell you, write a formation for C2H6, ethane gas. Okay, so you work backwards. So you have to find out what reactants that are used to make C2H6. So you know you need carbon and you need hydrogen. Hydrogen's diatomic, so you gotta make sure you put H2. And then lastly, you gotta make sure you balance it, making sure that the product is 1 mole. So you might have to use fractions. In this case, you don't, because you need 2 carbons, because there's 2 carbons on the product side, and you need 3 H2s because there's 6 H's on the product side. Okay. Enthalpy of combustion. Exothermic reaction, it always releases energy. So that's how you tell if something could be combustion and could be formation. If the formation is endothermic, then it can't be a combustion reaction because it's always exothermic. So some 2 types of reactions. Again, the rust one is exothermic because it was negative delta H. And then graphite to form carbon dioxide is also exothermic, releasing energy. So to write a combustion reaction, really the main thing is making sure oxygen is diatomic. So don't forget that O2 is oxygen, not just O. So here we have ethane gas reacting with oxygen, making water and CO2. Typical combustion reaction, and you just gotta balance it. So normally you balance hydrogen first, and you put a 3 there because there's 6 hydrogens on the reactant side. But you should know, or the shortcut for this is that water can never be odd. So to make it even, you change that to a 6. Just a little shortcut, save some time. So then you balance balance hydrogen on the left side, so you got to put a 2 there. Then you balance carbon with a 4, and then oxygen gets balanced with a 7, 14 oxygens. Alright, so here is your assignment. You write 4 different enthalpy reactions. Make sure they're balanced with the correct standard states. So make sure you know the standard state is whatever they are at room temperature. And then if it's a formation reaction, you gotta make sure that you have it balanced with 1 mole as the product. So you have the formation of water, formation of CO2, formation of methane, and then you have to write the combustion of methane as well. This will come in handy in our class discussion. Okay, if you have any questions, let me know, and we will talk about this in class.